Good morning, good afternoon, and good evening. Thank you for joining. I am Zane Hamilton with the Solutions Architecture team with CIQ. For those of you who have been with us before, we appreciate you coming back. For those of you that are new, welcome. We would ask that you like and subscribe so that you can stay up to what's going on with CIQ. Today, we're going to be talking about provisioning, and we're actually going to be talking about provisioning with the founder of Rocky Linux and CentOS, as well as many other open source projects, Gregory Kurtzer. If we could bring Greg in. Hey,
Hi.
Greg. Thank you for coming. So today we wanted to talk about provisioning, and I think if you would just give us an idea of the provisioning from your mindset and kind of where you're coming from, because I think if you look throughout the industry, provisioning can mean a lot of different things to a lot of different people. So from your perspective and from where you're coming from in your background, what does provisioning mean?
So, great question. My background is in high performance computing specifically. I spent about 20 years-ish of my career doing high performance computing. So when I think of provisioning, I think of provisioning the HPC resource. And typically we're talking about provisioning the operating system in this particular case and management of that operating system. So provisioning to me is basically what is the most effective, fastest, and flexible way to provision an operating system out to, whether it be a small cluster of tens of nodes or a large cluster of thousands of nodes. What's the best way of doing that and managing the operating system on all of those compute nodes? So for me, provisioning is kind of about that high performance compute cluster and management of those nodes.
Excellent. So when you're looking at it from an HPC perspective, provisioning is not just server provisioning, it's like user provisioning, network provisioning, the whole stack, right?
Yeah, so we're starting from bare metal. So you can imagine it as somebody buys a high performance computing cluster. They roll in racks of compute nodes. In some cases, as I said, it could be thousands of compute nodes. They roll it into the data center, and you're basically provisioning everything from that bare metal up the stack. And so starting with that bare metal, you basically have to build, put your operating system, get your operating system to the node in a very, efficient and scalable manner. But from there, you also have to do things like, are there any custom configurations on particular nodes? Does that include network configurations? That includes service configurations? Does that include user configurations? And some of these can be provisioned or managed after the node has been provisioned, but some of them actually have to be before the system runs SBIN init. And SBIN init is the parent of all processes with PID number 1. So in some cases, we actually have to do customizations to each node that's being provisioned before we even start PID number 1. So there's some tricks that we have to be thinking about in terms of provisioning, but you're exactly right. Even though I think of provisioning as being that bare metal kind of base operating system, that base operating system includes a number of different facets such that the cluster can work properly. And again, that includes network, service configuration, user configurations and whatnot. Great question.
So you actually use an interesting word there. You're saying configuration. So whenever you're talking about configuration management and provisioning, are they different? Are they the same thing? Are they paired together?
Oh, that's come up a bunch of times in high performance computing, especially as we're talking about and thinking about provisioning of the operating system. Excuse me. So Warewulf and other cluster provisioning systems will typically do some basic rudimentary configuration management. But that rudimentary configuration management, as I kind of alluded to a moment ago, occurs in many cases before the operating system has booted. So you're basically making these configurations like your network configuration, for example. You want to have your network configuration in place before you call SBIN init, and then SBIN init goes through systemd and starts all of your services, starts all of your devices. You need to have that network configuration already there. Same thing with things like fstab, right? You need to have your file systems already configured. You need to have, any service configurations configured before systemd runs those services. So there's a side of this configuration management which has to be very kind of lightweight and engraved into that provisioning system such that you're getting all of the nodes are basically getting their appropriate configurations, whether that be something as simple as just a network configuration and a hostname configuration, or that be something as complicated as a whole different operating system. You have to be able to manage that at the provisioning layer. And Warewulf does all of this for you, but it does not replace a more typical and much more fully fledged configuration management solution. So if you need something that's going to do much more complicated configuration management tasks, that's something that we would say, well, provision your base system with Warewulf, do your base configuration with Warewulf, but once that node comes up, run your configuration management services, so then you can actually then take over with your CM platform, whatever you're choosing.
Excellent, thank you. So I think one of the other things that I hear quite often in the conversations I have is stateful versus stateless. So when we start talking about Warewulf, how does that come into play?
So this kind of even goes down to the foundation of Warewulf and kind of some of its basic tenets of what differentiates and has differentiated Warewulf all the way since the beginning. So if I go back in time, let's see, it was created in 2000, 2001. Yeah, I'm way that old. Basically, at that point, high-performance computing systems were traditionally, as we were starting to make the bridge over into Linux, and the Beowulf was all the rage at that point, we were basically trying to figure out how do we manage the operating systems on, again, hundreds or thousands of compute nodes. And to kind of, again, put this into perspective, many organizations say, well, for every system administrator, maybe it's, if it's a high load, high complicated, systems, a system administrator may be able to do 50, maybe 100 separate servers. If they're really good, or if the systems are fairly similar, you might be able to get, hundreds. But an HPC system could be thousands. And we're not going to have, we need to come up with better ways of scaling. Scaling the system administrator's time, scaling how we're doing this. So there came to be toolkits on how to manage this. And there's various different ways of doing this. So one that was very big at the time was called Oscar. Oscar used a system or provisioning tool called System Imager. And System Imager basically allowed you to basically make a template of your operating system, and then it would blast that template out to all the nodes when you booted, and would write it out to the hard drives. And from that point on, all of your nodes are kind of provisioned, and then you manage them as a cluster of workstations, in a matter of speaking. There's other tools that leverage things like Kickstart, which is Anaconda's or the Red Hat, originally the Red Hat installer, mechanism for automating deployments of resources. So there's tools, so the ROX cluster system, not to be confused with Rocky, similar name, but ROX uses basically it's a turnkey system that basically uses Kickstart to basically provision out all the nodes. And Warewulf, though, approached this from a completely different perspective. Instead of facilitating the installation of a massive amount of compute nodes, let's completely remove the necessity to install any compute nodes. Let's just boot directly in to a runtime operating system. And all of a sudden, that kind of shifts the paradigm a little bit, right? So every time a node boots, our model was, let's just dump a real, a runtime operating system onto that. We're never doing an install. And then it runs directly from being booted. It runs kind of almost like a live OS or a live CD. And every single time, so when Warewulf boots a node, every single time that node boots, it gets the operating system byte for byte as it was intended by that node and all of the nodes above and all of the nodes below. And it makes it very scalable. It makes it very easy to maintain. And so when we talk about stateless in high-performance computing provisioning, we're basically saying that the operating system is not written in a persistent way to the storage. So this means that you could reboot that node at any given point, And as you reboot that node, it's always getting a fresh version of the operating system. Now, stateless is usually confused with diskless. And a diskless node, I mean, obviously you'd have to run that stateless, but if you have a disk full node, you can choose if you want to run that stateless or stateful. You can also choose, do you want to write that operating system to memory? And do you want to run it directly out of system memory? Or do you want to run that operating system off of that spinning disk? There's a lot of different kind of options in terms of how you can choose to provision that resource and that operating system to that node. Warewulf, the thing that's really differentiated Warewulf over the years is the fact that it really focused on stateless. So there were other systems out there that were focusing on stateful, and I mentioned Rox and Oscar. But Warewulf really focused on stateless operating system management. And again, there's a lot of benefits in doing that when you're dealing with a large system at scale. A story that I like to tell is, at some point we had a compute node in a very large cluster. We had one compute node that would always segfault on one application. And as we would run this, this application across all the nodes ran it perfectly except for one node. But it was a seg fault. And, typically when you see a seg fault, you usually are going to assume that there's something kind of weird going on with the software stack or, something's going on, but it's usually software related. But because we were using Warewulf, and I knew with fact that the nodes above and the nodes below are running perfectly, but this one node is having a problem, we knew it was a hardware issue. So I packed up this node and I sent it over to the hardware vendor, and they said, "What's wrong with it?" And I said, "I don't know." it's segfaulting the software. And they're like, "Yeah, that's the hardware? You sure?" Said, "Yeah, I'm pretty sure it's the hardware." And they looked through it and they didn't see anything wrong with it. They wanted to send it back. I'm like, nope, there's something wrong with it. Finally, they get around to checking the power supply under load. And it turned out that the power supply under load was not providing enough juice for the motherboard in the system. And that's where I don't know how, I'm not a hardware guy, but that's how it somehow was interpreted by the kernel. Something ended up coming up a little bit short on power, and it was interpreted as a seg fault, not a hardware failure. And they put a new power supply in the system. System ran perfectly from that point on. So it kind of changed the paradigm in terms of how do we maintain and how do we think about maintaining these large systems, and especially when you consider mean time between failure is actually not that bad unless you're looking at 1,000 plus different nodes. Then your mean time between failures is actually, it hits quite often. So how do you manage things like this? How do you mitigate that? Again, with a stateless operating system, provisioning system, you can basically just take out that node, put a new node in, change the configuration to say, okay, the hardware address of this system is now changed. Just turn it on, and it has now completely assumed all of the responsibilities and roles of the previous node that was there. Very easy to deal with. So stateless versus stateful. So
this sounds, just using something that a lot of people are talking about today, is a very popular topic. This sounds a lot like containerization to me. So how is this, or how is it, or would it be related in any way to containerization?
So that's a great question. So when Warewulf was first conceived, and very similar to Oscar, as I mentioned before, using System Imager, it had the notion of a golden image, this base template image of what you're using for the template to provisioning out all of your compute resources and all of your compute nodes. Excuse me. So in Warewulf, we did it a little bit different. We basically had a directory. And it was a chroot directory, if there's any engineers or admins in the room. It was a chroot directory, which basically allowed you to have like another root file system in a directory location. And Warewulf leveraged that as a template to make the operating system, make the bootable operating system for all of the compute nodes. Now, we didn't know it at the time, but what we were actually using was basically a container. And I know a chroot and a container is very similar already, but that's basically what we were using. We called it something different. We called it the virtual node file system, and we managed this virtual node file system using tools that were, well, quite honestly, very similar to containers today. So one of the big switches that we just made with Warewulf v4 is that we basically just embraced the container ecosystem directly. So instead of us kind of having a separate version of this that we were basically using as a VNFS, we basically said, well, it's not a big jump to just say, well, let's just start using containers. This has the effect that all of the existing tooling and everything that people are doing today with containers, to build containers, to secure containers, to validate containers, well, we can just leverage that directly in Warewulf now. So that was one of the biggest change that we made with Warewulf v4, is it now is basically an OCI compliant provisioner. And this means that we can basically, you can use any of your Docker recipes, your Docker files. You can use Singularity, Apptainer. You can create your container. You just point Warewulf at wherever that container exists, whether it's in an OCI registry or whether that's on your local file system or in the local daemon running. And you basically say, I just want to import that into Warewulf. Once you've imported that into Warewulf, you can say, okay, I want these 1,000 nodes or however many nodes you have to boot on this container. And what Warewulf does is it actually not only blasts, the operating system out, it's actually blasting a container out to all of the compute nodes. So you're basically running this container on bare metal. And as a result of it, again, we get to leverage all of the existing tools and capabilities that people probably already have today with regards to their containers and how they're managing containers and so on and so forth. So all that can be basically directly imported into Warewulf, and then you can provision out those containers.
It's awesome. So I think we've talked about kind of what it is today. I think a lot of people are interested to know, 2002, it's 20 years ago. How did you get started? I mean, what brought Warewulf to life? What story did you have, or what were you going through at the time that made you decide you had to go do something else or do this? Obviously, it's solving a problem. So how did it become?
So my background is actually in biochemistry, and I made the jump, the leap into Linux and open source as I was trying to solve problems, computational problems for biochemistry, and I got so excited over being able to do this in open source, and I was so enamored with what we've been able to do in Linux and open source and whatnot that I pivoted my whole career on that. As a result of that, I ended up landing, going through some startups, but I landed at Berkeley Lab at the Department of Energy, and I was joint appointment to UC Berkeley, and I did projects for UCOP and whatnot. But when I first started this, I went from not only scientific computing, but we started, the advent of 2000-ish was kind of HPC, cluster computing, Linux cluster computing was starting to become a really big deal. And so one of my first tasks when I joined Berkeley Lab was to basically start, building up some big HPC clusters. And at the time, as soon as I walked in the front door, I was basically tasked with an existing load of projects, and I was completely taxed out. Like I was at 100% utilization, if not more. And they basically said, okay, and now we're going to basically add, some pretty big clusters to the mix, and we need you to maintain this. And I started looking at, well, okay, there has to be some way to help me with this, because I am not going to, physically install, 100 computers and then
sleep,
basically,
right? Who needs sleep?
Exactly. Well, I mentioned this was a government position too, right? So I was basically, which means we're already overworked, by the way. So this basically means that I'm trying to figure out what is the best way to manage these systems, to install them, to build them, and then maintain them over time. And so I was looking at different toolkits and what are people using, and just honestly, none of them really spoke to me in terms of the way I wanted to manage this. So I developed a prototype, very similar to it seems like many of the things that I've developed over my career. I developed a prototype which was close, but at the same time, completely wrong at exactly the same time. So Singularity started the same way. Singularity version 1, those of you who followed Singularity know that it started off basically being almost like Ubuntu snaps. and then ended up morphing into what you know today as being Singularity and Aptainer. In this particular case, I worked at a previous organization called Linux Care, and we were very well known for creating these little bootable business cards that you can put into a system. It was a little rescue CD. And I left there thinking all of the world's problems could be solved with a little bootable business card. And if everybody just carried these around, you can have everything you ever wanted. Obviously, computing-wise, maybe more. I don't know. I started Warewulf, actually created ISO images for all of the compute nodes. So they were stateless. It's just I wasn't using the network to transmit them. And I went to Linux World in, I think it was 2000. And I went and I talked to people about this and I presented this. And the feedback that I got is, wow, we really like the management paradigm of what you're doing, but good God, what are you thinking with these ISOs? That is just such a horrible idea. And they said, you know, there's a booth over there called Etherboot, which was the predecessor to Pixie in many regards. It says, go talk to the Etherboot guys. I'm like, Etherboot, oh, cool. So I went over and talked to them. I learned everything I could learn about Etherboot in a few days. And it just took me like 4 days to port Warewulf to now you go use Etherboot. And Etherboot was basically a little firmware that you can either flash to your network card, or you can boot on a floppy that just had this little piece of firmware on there, which basically set your network card as a bootable device by basically loading an option ROM into the BIOS to do that. And then the network card would actually do the Pixie booting. Well, it wasn't Pixie at the time, but it would do something like Pixie. And that was then that's where Warewulf really then took off, is once I got that built up and integrated. And then it seemed like organizations all over the place started adopting Warewulf, started going to supercomputing, and everybody was talking about Warewulf for quite some time.
It's awesome. I'm not going to say that I've ever used a Linux CD because I have. So, rescued some stuff. So I know that we've talked about Warewulf. I know a lot of people are here because they want to see Warewulf. So I know you've prepared something for us. Let's see what you got.
Yeah, absolutely. All right, so I put together some slides real quick, just so you can kind of see. We're doing more than just Warewulf, obviously, as a company, and I'm not going to go into this. I don't want to sound sales or marketing wise, but if you're interested in any of these things, definitely please let us know. And Warewulf is a big thing that we're going to be talking about. So when we talk about Warewulf, we usually describe it as, even the name comes from, it's a software implementation of the Beowulf. And that's why Warewulf is spelt totally wonky. As a matter of fact, if you ever ask me to spell werewolf as the big, monster human dog thing, I can't. It actually doesn't feel right to me. There's something wrong with it. So Warewulf. This is how it's just engraved now at this point. But basically, Warewulf is a software implementation of the Beowulf, and the Beowulf is a specification for how to build a cluster using commodity parts, using Linux, using open source, and it's an architecture. And this architecture is roughly drafted as you see below. Right, you got your user workstations and users SSH across the network, and they basically get into a control system. That control system may have a file system attached to it directly, and it's sharing it out, or this could be some sort of network attached storage, and it's sharing it out. But then you have a switch, you've got a private network where all of your compute nodes reside, and these compute nodes may actually even be on another network that may be a high-performance data network, something like InfiniBand. And this is basically kind of like a very basic Beowulf. First and early versions of Warewulf were designed to solve this. But as we got more and more complicated and we were looking for more features in what these systems look like, we started adding to it. And we started adding to it in such ways that, again, users would basically be SSHing in. We'd become basically directing them through a reverse NAT in our firewall to land on our interactive nodes. And the compute resources are in typically groups now. And they're in groups because you may have different vintages, you may have different people that own different sections of them and whatnot, but you have these different groups of compute nodes. You may have separate networks kind of dedicated to each one of these groups, and so on and so forth. Warewulf and or provisioning and scheduling are usually done in some sort of redundant resource. And again, you've got your shared storage. And typically, by the way, just you usually have like a home directory storage and some form of parallel scratch storage that's very efficient. Now, Warewulf now needs to be looking at this not only as just a completely flat system, like you may see here, but multiple flat systems. And Warewulf now was built around the idea of how do you maintain, not only these simpler kind of flat systems, but how do you maintain systems that have additional depth and additional complexity. And when we built these systems at Berkeley and Berkeley Lab as well as UC Berkeley, we basically have, there's no state in the entire system except for the Warewulf master. So even the interactive nodes ran stateless. The entire architecture was stateless. And this meant that any system could basically blow up and we can just replace it and we didn't lose anything. There was no context that was ever lost. So this was how we were thinking about building systems, and this is kind of how Warewulf is envisioned today. And you're going to see in just a moment how you can have node configurations and then node profile configurations that are completely cascading, and it really facilitates anything from, again, a more simple kind of turnkey model going all the way up to something that may be have a lot more need for flexibility. So if we take a look at, so I've already set up Warewulf and I've basically built a node on this, and it's a virtual node, so we can hack around at this a little bit and take a look. I'm right now, and I installed it to user local just because I didn't install it via package, and user local is what I do. So it's in user local, and inside of etc Warewulf, you'll see you got a few files. And if I take a look at the nodes.conf, you'll see two major sections. Now this is YAML. And we've got two major sections in it. We got node profiles and we've got nodes. Now, nodes are pretty easy to imagine, right? This is a single node, right? This is the configuration for a single node. We've got some information in here that is maybe specific for this node. And if you have hundreds of nodes, you may want to consolidate some of that information and configurations to profiles. Now, every node by default gets a profile called, well, default. And that means you can actually add your configurations to the default profile. So for example, in this default profile, we have a container name, which is Rocky 8, and we have a kernel version. And I'll show you basically how I got these into the system here in just a moment. But basically, what I end up doing is, because node 0 is part of this default profile, and this profile has these values, node 0 has those values. And I can supersede those. I can have multiple profiles that supersede other configurations, and it's extraordinarily flexible. You can see in terms of network devices, we have a default network. And what you can see is basically I have the net mask being kind of globally defined, but I have the IP address and the MAC address being defined specifically on just this one node. So obviously I don't want to put my IP address or my hardware address, my MAC address, in a profile, because then all nodes would have the same IP address and same network configuration. So that I specifically put into this node profile. So this kind of encapsulates what an entire system architecture would look like. And it gives us the ability at a very high level to actually do very kind of cool things. Now I'm showing you this nodes.conf, and you can edit and work with this nodes.conf directly if you want, or you can use configuration management, but most people use the tool www-control. Now, www-control is basically the primary interface for Warewulf. So you can do www-control, for example, node list, and I want to see all attributes. So I'm going to use the -a, and you can see now, if we had many nodes configured, this would basically be a giant list. But you can see in node 0, we have all of these different fields or keys that are associated with this. We can see all the different values for them, and we can see where did we get that configuration. If it says default under profile, that means we basically got it from this default profile. So for example, container name and kernel version came from the default profile. And that's exactly what you see here. This is listed here because there are some configurations that may have many node profiles, and in some cases it's best to see, where is a particular value coming from. So if we may have, let's say, a default profile, but on some nodes I want to test a new kernel, I can have another profile for a new testing kernel and then add that profile right here, and we'll basically be able to have, a certain group of nodes testing that newer kernel. It's extraordinarily featureful, and I don't want to get too bogged down on this, but I really wanted to explain this because it is extraordinarily capable with regards to configuration of nodes. So as we're looking at building systems that may be more complicated like this, it makes it very easy to group these nodes together with a profile and then define all the attributes for this profile. Warewulf gives you that functionality very, very easily. Okay.
Greg, real quick,
Yeah.
I got a question for you. Whenever you said you just installed this. What is required to install the Warewulf controller? What does it look like, or how complicated is that?
Good question, and thank you for bringing me back to this. I meant to show this, but I totally forgot as I just wanted to jump into the tech. If you go to warewulf.org, you can click on Docs, and from Docs you can click on Quick Starts, and we have an Enterprise Linux 8 Quick Start. And as you go through this, I'll quickly run through this so you can kind of see how this operates. The first section is just installing it from Git. You can install it from packages, from the releases, etc. But this is just from Git. And it's basically you install the dependencies, you do a git clone, you do a make all, and then sudo make install. Super easy install. Excuse me. Once you've done that, you basically just run these commands to configure the firewall appropriately. This is the warewulf.conf file. You're going to edit this and just make the appropriate changes. Probably going to need to edit your IP address, maybe your net mask, and then you probably also want to take a look at your range start and range end. For the most part, everything else is going to be pretty standard. Then what we're going to do is you can create some, if you want systemd to run this, you basically just create the needed users and whatnot. And then basically just start Warewulf from systemd. And at this point, we now have Warewulf installed. Now what we're going to do is we're going to run a www-control configure all. What this will do is this will basically go through all of the system services that Warewulf needs for it to boot. So for example, it's going to need things like Pixie. It's going to need Pixie, has certain requirements like DHCP and TFTP. It's going to need NFS to be running. If you want NFS to be running via this configuration file, it'll set up DHCP, as I mentioned, make sure TFTP is running properly and drop the appropriate files in there. So this will just kind of configure your underlying system. And this has been tested and works on Enterprise Linux variants, on SUSE variants, as well as Debian and Ubuntu. From here, now we're going to start basically working with Warewulf directly. I showed you that I had a container called Rocky 8. This was how I got it. I just did www-control, container, import, and I pointed it at a Docker registry. You can reach this from anywhere. This is public on Docker Hub. And you can then import your Rocky 8 image. We're going to name it Rocky 8, and we're going to set it as default. What setting it as default does is it basically adds it to the default profile, as you see right there. Then what we're going to do is do the same thing with the kernel. We're going to www-control, kernel, import, and we're going to give it our current version name of the kernel that we're running, and we're going to set that as default. What this is going to do is it's going to take a snapshot from your host. You can get the kernel from a variety of other locations if you wish. Just look at the help output for kernel import. But what this will do is in its simplest form is take the kernel running from your control server. So if you're running GPUs, if you're running InfiniBand, make sure those drivers are currently installed on your host kernel or whatever kernel you're importing from. And Warewulf will automatically pull all of those kernel drivers and support for that kernel and then import that into Warewulf. And again, the set default then puts it right here. Now, once we've done that, and then if you didn't use the set default, this is how you would set your profile to basically be exactly as I just showed, www-control profile set. We're basically going to set the default profile. This just basically means assume yes. Set on the default profile, we're going to set the kernel and we're going to set the container. The next thing we're going to do is we're going to set on the profile again, we're going to set a basic network configuration. And again, this is exactly what has already been done, as you can see here. I didn't set the gateway though. I guess I was slacking on that. Slack has a whole new meaning now, doesn't it? I can't use that word anymore. Okay.
Confusing.
And lastly, we can now add a node. And you can do www control node add, give it a node name. And then we're basically going to specify some network information. And we're going to make this node discoverable. This means that when the node boots, it will automatically be added to the Warewulf database, and it'll be automatically configured. So it will automatically put in this MAC address onto whatever network device you have set as the default. So it'll automatically do that. The next thing to talk about a little bit about is Warewulf overlays. What we've just done so far is we've taken a container out of Docker Hub, and we're going to blast this out to n number of hosts. That actually would work perfect if every host was identical. But we do have some node-specific things, everything from network to service configuration, user configuration, as we were talking about earlier. So some small amounts of data and configurations may need to be changed on a per node basis, and that is done via overlays. And I'll show some of these overlays features here in just a moment. But overlays is basically a way of adding information to a provisioning system using text templates. And I can show that here in just a moment. All right, so that's basically what I did to get this system up to speed. And that's where we kind of ended up. So I'm going to start off by showing overlays. So if I do a www control overlay, you'll basically see all of the subcommands for overlay. If I just type in www control, you'll see all the primary commands. So we're going to do www control overlay. From here, let's do a list. Let's see what exists on this system. And you'll see I've got two overlays. One is called generic, and one is www init. To show how this relates to the node, I'm going to do a node list -a again, and you're going to see we have got two overlays here, system overlay and a runtime overlay. The system overlay we're calling on is www init, and the runtime overlay is generic. These are in parentheses because they are not a configured attribute in the node configuration, which is up here. So that means they are defaults. If you set them in the node configuration, the parentheses will go away and it will look like everything else. And it'll be whatever you set it to. But if they're not set, those are the defaults. So the www init and the generic overlay can be found here. Now, if you want to see what's inside of them, you'll see, for example, the generic overlay has 7 files and the www init overlay has 46. So let's do this. And we're going to do a list. This shows us all of the different files, their permissions, and ownership in the www init overlay. And you can see all the different files that are basically going to be provisioned with this www init overlay. Notice some of them have the ending or the suffix of .ww. This indicates that this is a template file. And just like autoconf with the .in, as soon as this gets resolved for a node, the .ww will disappear and the contents of this file will automatically get replaced with whatever templates is in there. So I'm going to show one, which is this one. So if I do www control overlay edit, so the first thing I need to do is tell it what overlay I'm going to be editing a file in, and do that. And when I do that, you'll see this looks pretty much like a regular ifconfig file, except for it's got these template macros in here. And these template macros get replaced for every node that this is getting provisioned for. So this gives me the ability, with a single template or with a single overlay, I can actually have any number of nodes booting with unique configurations for each one of them. And again, the text templating language is actually very featureful. So if there's anything that you want to include, anything, conditionals, loops, ranges, it supports all of that. So it's very easy to customize this, with very large granularity. Like there's a lot you can do. So there's a few other pieces in here I can demonstrate, and I'll show you this one real quick. So www control container, because we talked a little bit about containers. So www control container, and we're going to do a list, and you'll see I've got one container imported called Rocky 8. It's built and it's ready to go, and it's configured on one node. So we could do something like this, container shell Rocky 8. And you can see I'm now sitting inside of that environment. All right, so if I do cat etc os release, I'm actually sitting inside of this operating system, this VNFS or this container. And I imported that container just out of Docker Hub. If I exit this, it will tell me it's going to rebuild the container automatically, but it skipped it because it's current. It quickly did some timestamp comparisons and realized it doesn't need to rebuild anything. If you want to install something into this, you can do something like this. I'm just going to demonstrate it with the etc. But the host etc directory, I'm going to put into the container's mount directory. And so if I do this, you'll see I've got all the files there. So if you want to install something like the MoFed user space component, you can put that, you can get that into the container by using a bind and then doing an install, just as you would with any other container. Or you can have that built via whatever CI pipeline you're using to manage your to manage all of your containers and building your containers. So I've kind of walked through the general interface of www control. I don't think there's anything else to really talk about in terms of specifics that I haven't shared already. The goal of Warewulf is to be very simple. It's to be lightweight, it's to be simple, it's to be easy to use and very flexible. So the commands that you'll see here, they should be fairly self-documenting, right? The configure command is basically just to manage the system services as we did at the very beginning. Container we walked through, kernel I demonstrated, node I can show that in a little bit more detail. We can add nodes, we can use IPMI, and at some point we're actually working on some Redfish integration, so you can get a console on that. You can look at sensors, you can set status, and whatnot. And when you do, for example, node status, you're going to see we have this node, but it hasn't booted yet. So there's been no last seen. So when we boot the node, we're going to actually watch this and see what happens. Let's see, we also have profile, which is the interface for managing profiles, different profiles. We've got power. This is basically for power management. When you do things like you want to reboot the entire cluster, it will automatically manage a parallelized fan out with an appropriate number of concurrent tasks so it does not completely overload your network. Little things like waiting, half a second to boot each node as you're going through that loop actually has a profound effect in terms of booting efficiently. Little things like that. Also, DHCP is very not scalable. And then server is basically the Warewulf daemon that is running, actually comes from this binary, but you can definitely interact with it here. But since we're running this through systemd, it's better just to let this be and let systemd kind of manage this. And you can see, so system control, and you can see it's in there, and it is properly running. So what we're going to do now is we're going to actually test boot a node. And we're going to add the W option to the, which is to watch this update. And if I come over here, I just so happen to have a virtual machine that we are going to boot. And this has been configured to PXE boot. By the way, doing PXE booting on VMware Fusion, as you can see that I'm doing, has gotten incredibly difficult because now everything is using Max DHCP services and whatnot. So if anybody wants to know how to do that and they get bogged down with DHCP issues, send me a message. I wrote a quick script that just blocks Mac's ability to do this. So when you basically boot this up, you'll see we're doing an EFI, UEFI boot, and it's basically going to start with PXE, and you got to watch fast because it moves pretty quick. But you can see now we're basically sending it the container, which is happening down here at the same time. Next, we're going to send it the different overlays. Here's the KMods overlay, system overlay, runtime overlay. Once it's got that, it now is managing a little bit on the back end. Now it's doing some basically booting through Warewulf and init, and we're now done. It was super fast, as you can see. There was no operating system installed on this node whatsoever. Everything just came over the network. And when you're actually booting on real hardware, it's actually faster. So granted, I'm using a fairly small and basic container. So if you have a bigger container, it will take a little bit longer. But it is a very fast provision. And again, it's designed to be very scalable. For lots of nodes booting parallel. And the default update, and I didn't talk about this before, so I'm just going to mention it real quick. There's multiple overlays, as you saw. And I can even show you the different overlays. So if we look at, we're going to kind of get into the weeds a little bit right here, but if you look at the default iPXE script, you're going to see that we've got 4 pieces that we're pulling into an initRD. And what you're going to see is we got our base container, we got our kernel modules, we got our system overlay, and we got our runtime overlay. What we're actually doing is overlaying all of these overlays on top of the container. And what that gives us the ability to do is to start with a base and then add in the appropriate necessary bits that we need for this node to operate properly. Now, the system overlay is only provisioned once at boot, at provision time. The runtime overlay actually happens reoccurring. So if you have user accounts, and we can look at what was inside of that. So if we do the overlay list, remember the generic. So if we do www control node list -a, you'll see that the runtime overlay is set to generic. So let's take a look at what's in there. Overlay list generic -long, and you'll see we basically got user information in here. So we've got our groups, host file, and password, as well as root's SSH authorized keys. But basically, this gives us the ability for root now just to drop into that node easily. But basically, what we have now is we have things like the password file, and that password file is going to be automatically updated as users are added into the host system. So if you add a user into this host system, because of this overlay default configuration, within 1 minute, all your nodes will automatically be configured to have that user account added, because that's the update interval for the runtime overlay. And you can see, as soon as this hits basically 59, you're going to see another message, another request to get the update from this node that's booting. So you can also sort, by the way, this file or this output based on what nodes have not checked in. You saw it turn yellow there for just a split second, and that's just because it hit that maximum time for the overlay request, and it said, well, if we don't see it in the update interval that we're supposed to see it in, then that's a warning. So it basically turns to yellow. And again, you can search for all of those sorts of things as you are managing your node. So if you've got 1,000 nodes, sometimes it's hard to find the one node that didn't provision all the way, or the one node that didn't reboot via its IPMI command, which does happen. Or there was a DHCP error. Again, I kind of alluded to it. DHCP seems to be one of the most limiting factors of scalability of parallel booting of hundreds of compute nodes at once. So you end up with DHCP conflicts and whatnot. So you can quickly see what nodes have been provisioned and what nodes have not using this tool. I think I've pretty much gone through everything that I plan to go through. Are there any questions? I haven't been...
We do have several questions. Alan asked some good questions. One of them we actually covered when you talked about containers. He was asking if you can integrate tools like boot to container, but he said that one was been answered. So this one's got a lot of parts to it, Greg, and I'll try to read it. Oh, there we go. Perfect. So is there an ability to have tight integration with baseboard management controllers as well as data center layout, switch configuration, and related topics? Let's start with BCM. Is it possible to do essentially everything that Warewulf wants to do through the pre-OS polling configuration file preparation by integrating with BCM's tools for each node? with open source software such as IPMI? You kind of hit on IPMI, but I think there's a lot in that question. So
Yeah. So the problem with using BMCs is it's not a standard interface for every vendor. So everybody's done their BMC differently, and even many vendors have actually done IPMI differently, depending on what additional features they're trying to add. Now at this point, IPMI is kind of stabilized, but the BMC controllers are very vendor specific. We do not have a direct integration into the BMC controller with one major exception, which is to help secure the provisioning process. You probably noticed when we looked at, where's my mouse? There we go. When we looked at overlay list, generic, and we looked at the files, you'll see files like the password and group file are there. Now, granted, there's no passwords in the password file. Which is, we stopped doing that like 20 years ago, more than 20 years ago at this point. But there's still user account information in that password file. And you may have other things that you put into these overlays, which you may not want users to find. Because we're using TFTP to download all this stuff, to download the first stage, and then we're using HTTP via PXE, it doesn't give you the option of having a whole lot of security. So what we've done, and if we look at the default iPXE file, you're going to see that we're using things like the asset key and the asset tag. So the only thing we really interface with the BMC with today are things like the hardware's UUID and the asset tags. And if you specify, did my voice just crack there? That was funny.
That was funny.
If you specify an asset tag on that hardware, it's interesting because users cannot get to that. It requires root to be able to get to that asset tag using something like a DMID code. But it gives us the ability to leverage that asset tag as almost like a key or a token, that unless that token is properly passed to Warewulf, Warewulf will not hand out any of this information to anybody requesting it. So it's actually a way that we can gain some security optimizations through this booting process, which, of course, whenever you're talking about security through provisioning, you have to have a root of trust somewhere. And this gives us a very easy way of kind of managing that root of trust, which is directly on the hardware via the BMC. And I don't think this answered your question directly, Alan, aside from it was a very fancy and long-winded way of saying no.
So, Alan, I know you sent a link about some things that you're working on as well. I know you and I have talked about Redfish before. It's certainly something that Greg and I can come back and follow up with you on and have the conversation. Let's see. One of the other questions we have is from Maria, asking about what types of functionality would not be possible to provision through Warewulf? Like, what is not a good use case or instance for Warewulf?
I gotta say it. Windows. Warewulf will not do Windows. That's the big one. There are a few types of operating system images that are difficult with Warewulf. For example, if you have very, very large operating system images, it can be very difficult to deal with the provisioning of those. So it's more optimal, and especially just because of building a good big, large, scalable system, you do want to have small operating system images. And if you have more complicated requirements, containers is actually a better way to manage large dependency stacks and whatnot than putting it directly on the base operating system. But if you have a very large operating system image, it's difficult from a scalability factor of getting that out to all of the nodes in an efficient way. There's also the second piece, which is we are consuming memory for those operating system images. So if you have a big operating system image, hopefully you also have a hard drive that you can set up swap on. If you want to set up a swap space on your hard drive, you simply put that into your FS tab, and Warewulf will, or rather the kernel, will automatically swap the space we're using in memory as it's needed by applications. So this whole operating system image and memory will end up being swappable. So as long as you do have a physical disk on your system, just set up a swap space, and that mitigates the issue.
Thank you. Herman, I believe your question was kind of in relation to what Alan had posted. I could be wrong, but I think you're kind of referring to what Alan had talked about. That's something that would probably be better if we followed up with you. So we'll get with Alan, and then we'll get with Herman.
Well, real quick, I could also say that the you can use Ansible playbooks or any even configuration or system management toolkit in Warewulf. There's two ways that most people think about it. The first way is kind of after provisioning. You use it to take over on the configuration management instead of using Warewulf for that, which, to be blunt, Warewulf is very basic with regards to how does it do configuration management. It's very simple. And you can't do a lot with it, but it gives you that core functionality pre-running Espen and init that you would need. But can you put that question up now? I'm blanking out on Ansible. Oh yeah. So the second piece of how people use Warewulf and Ansible is if you have multiple Warewulf control nodes, or managing your Warewulf control node. It's funny, as a jab to HPC people like myself, I've heard a number of people from enterprises and clouds saying, what do you mean you use SSH for nodes? We don't even want our administrators using SSH anymore. Everything should go through something like Ansible. And so we've heard that a number of times. You actually can manage your entire Warewulf control server using Ansible or other configuration management, and you never actually touch it. So that's the other way I hear of people using Ansible with Warewulf.
So here's the question that you're going to love, Greg. It's from Kenneth. Thanks for the question. And he's asking about, is there a tool that will help you lay out groups and nodes in a visual GUI mode? It makes configuration easier.
So not at this point, but it is something we've actually talked about quite a bit. Because we're dealing with straight YAML, building a graphical environment around management of that configuration file actually is not difficult to develop. It's just something that has to be developed. So that thought has actually been broached. We've considered it, and we're actually planning on doing it. We just haven't done it yet. And Kenneth, great to see you again. And Alan.
That's all the questions we've had come in. I mean, if you guys have other questions, post them quickly.
The biggest clusters, I can just blab for a little while we're waiting for questions. Some of the biggest clusters that I know running Warewulf, people always ask me, one of the frequently asked questions is, how many nodes can you boot on a single Warewulf control server? And the number that I usually recommend is, I say, it's good for 1,000 to 1,500 nodes. But I know people doing many more than that. The biggest system that I know of is about 3,500 nodes on one Warewulf control server, without any redundancy and without any load balancing. I don't recommend doing that. But the nice thing about the provisioning system is it does not have to be high availability. Once that node has been provisioned, you can actually take the entire provisioner offline. And if it goes down, all of those nodes are still provisioned. You're not actually affecting anything. So it does not have to be high availability. In some cases, you may want it to be load balanced if you're trying to boot thousands of nodes at once. And I have seen RFPs that says all nodes in the system, whether it be a 100-node system or it be a 1,000+ node system, the entire system needs to be booted and provisioned in less than 5 minutes from scratch. And Warewulf, actually, generally speaking, is very good at that. Granted, you may have to build up your control server with a nice, very fast Ethernet controller, and or split and bisect it between two separate broadcast domains. So there's different ways of thinking about that, different ways of handling it, but you can definitely boot very large systems with Warewulf very, very quickly.
It's fantastic, Greg. I don't see any more questions coming in, and I think we're a little bit over. So, Greg, thanks for the time. It's always great to hear the stories of how this stuff started and be able to see it in action. So really appreciate it. Looking forward to what else we talk about later.
Absolutely. Thank you, everybody, for coming.
Join us again next time, guys. Appreciate it.
Bye.
Thank you.